Our topic today is CSI Statistics, helping students become data detectives within the GAISE framework. I'm very pleased to introduce our speaker today, Darren Stones. Darren teaches mathematics at the Lawrenceville School in Princeton, New Jersey. He earned his master's degree in mathematics at the University of Michigan and has been active in the AP statistics arena for many years. He's also a co-author with Daniel Yates and David Moore of a textbook that I think is just excellent. It's entitled Statistics Through Applications. So, Darren, please tell us about helping students become data detectives.
Thank you very much, Paul. Good to be with everybody today. I'm particularly excited about being able to share this investigation today. I want to start by giving some credit to the people who originally started developing this. About 3 years ago, members of the ASA NCTM Joint Committee decided that it would be very helpful to have a set of resources for classroom teachers and students to use in order to support learning about how to design and carry out surveys, experiments, and observational studies. There certainly were books out there that had been written about the topic, but there was no good set of activities ready for elementary, middle, or high school classrooms. And so members of the committee started trying to envision what activities would be helpful. And so what I'm going to be sharing today was actually the fruit of the labor that was begun 3 or 4 years ago by members of the committee. And obviously I'm eager to hear people's reactions to it now that we're actually that we have something to share. Before I do that, though, I wanted to mention that when we were originally writing the activity, we took a close look at NCTM's data analysis and probability standard. We wanted to make sure that anything we did supported the NCTM standards. And so when we put that up as a measuring stick, we wanted to be sure that any of our investigations required students to formulate questions that would require them then to collect data, organize the data, and analyze the data, to be able to use appropriate methods of data analysis and to have to choose between alternative methods, and then to draw some sort of conclusions that go beyond the data that are in front of them. And so I hope this investigation will do all those things. And the NCTM standard also included aspects of probability, which we've attempted to approach primarily through simulation to make them available to a broader audience. So while we were working on the initial plans for these investigations, this thing called the GAISE report was being put together by members of the ASA, and we actually stopped working on the investigations in order to read the GAISE report and digest its contents. And we were particularly excited to see a statistical problem-solving process detailed as part of the GAISE framework. So as we looked at that four-step framework for problem-solving, we saw some of the same things that you just saw in the NCTM standard: formulating questions, collecting data to help answer those questions, analyzing that data, and then interpreting the results of that analysis in some context that's larger than the original data. So we saw a really natural fit once we put the two together and thought we could go ahead with this project. We're now calling it the Making Sense of Statistical Studies project. Our goal at the end is to have a standalone capstone experience for high school students that actually could be begun as early as middle school. That experience would be supportive of NCTM standards, the GAISE report, and also the College Board standards for college success that they released within the last 2 years. That it primarily would be focused on designing, carrying out, and drawing conclusions from surveys, experiments, and observational studies separately. So the investigation that we're going to look at today is one of the pieces of this Making Sense of Statistical Studies module, and it is in the section on observational studies, which is the first section in the module. So with that, I think I'll introduce you to the investigation, and once I've laid out the scenario, I'm hoping that some of you will jump in and offer an observation or ask a question. So here goes. CSI at school. Over the weekend, a student entered the school grounds without permission. Even though it appears that the culprit was just looking for a quiet place to study undisturbed by friends, school administrators are anxious to identify the offender and have asked for your help. The only available evidence is a suspicious footprint outside the library door. The mystery begins there. So the goal of this investigation is for us to use some data on shoe print length, height, and gender to try to help develop some description of the person who may have entered the school. Our wise school administrators decided to help with the situation by arranging for some data to be collected, and they were savvy enough about statistics to know that they should take a random sample of students from the high school and get data from that random sample of students. So the data I'm about to show you were the data collected by the administrators, and I hope you can see now the sample of data on shoe print length, height, and gender. So the first thing I just want to be clear on is to see if you know what sort of units the shoe print length might be measured in.
I guess would be centimeters.
So can we rule out feet or inches or miles or anything like that?
Rule out miles. Let's start with miles.
Miles are out. Feet are out. So if you're thinking English units, maybe you'd think inches, but that'd be a heck of a long foot. So it turns out that the administrators did use centimeters for the shoe print length. And
Inches.
height, yep, good again. Inches on height. And so for whatever reason, the administrators' measuring tools here in the office served them better to do the shoe print length by centimeters and the height by inches. And of course, gender is recorded as a categorical variable. So those are our data. So from looking at the data
Where's the height from?
the heights were measured for those same individuals. So for example, the first individual that the administrators measured had a shoe print length of 24 centimeters,
Okay.
height of 71 inches, and was female.
They're taken at the same time together.
Correct.
Got it.
You can picture the administrative office and these students being called into the principal's office to have their measurements taken.
Mm-hmm.
Sort of a humorous scene. So one of my questions is, just from looking at the presentation of the data itself, do you get any sense of a relationship between any of these variables?
I don't.
Does it seem just a bit overwhelming?
It does.
So one of the unfortunate realities of working with data is even when you get it well organized, it still doesn't speak to you very loudly. So perhaps making some sort of a graphical display would help illuminate what this data is trying to tell us. So those are the raw data, and we can refer back to them as needed. But meanwhile, I think we should go ahead and take a look at the questions that are part of this investigation. So to put you in the right frame of mind, we envision students would be working through this in the classroom, perhaps in small groups. And after looking at the scenario and examining the data a little bit, we come to a few questions that are designed to try to lead them through the investigation. And here's the first one. We suggest that the students construct some sort of comparative display of the shoe print lengths for the male and female students that were sampled. And the software I've chosen to use today is Fathom Statistical software, which I find really appealing and easy to use for students of varying ages middle school on up. It's got a really nice visual environment. So on your screen now, I've popped up a very basic Fathom document with the data from the shoe print study already loaded. You can see this little, we have a collection of what looks like gold balls in the top left corner.
Mm-hmm.
And those represent the individual students that were sampled. Each gold ball is one student. And then here I've collapsed some sort of, data table. Look at there. So one of the nice things you can do in Fathom is you can look at an expanded view, or you can collapse it down to a more economical view so that you don't have to take up your screen space. But those are those same data values that we saw earlier, the measurements of those individual students. So let's see what we can do in terms of making a graph. In Fathom, it's just a matter of going up to the toolbar, clicking on Graph, and dragging it out into the document. And as you can see, we have no graph. We have to tell it what you want to graph. And so the original question asked us to take a look at the shoe print links. I'm just going to grab that variable here and drag it onto the horizontal axis. And do you see a dot plot there?
You bet.
Mm-hmm.
Great. So it's immediate, dynamic, and we have a good display of the shoe print links data. Does anything jump out at you at this point?
Not really.
Okay.
Well, if they have like a 28 centimeter shoe print that they found, so we would know that there weren't so many students with that size shoe.
Ah, so you're thinking ahead. Very good. Yeah, I bet you are curious to know about the shoe print that they found on site. And if it, say, were around 37 centimeters, that would be especially interesting. We don't find too many students with that long of a shoe print. So it might help here to throw gender into the mix. And so Fathom will allow us, if we grab the gender variable, to add that in several ways. That time I drag and drop it onto the axis, and you can see that it's colored the male points blue and made them into squares, and it's left the female points as circles. Another option is to create separate plots by gender. So if I drop the gender variable on the axis instead of in the middle of the plot, it creates separated dot plots.
I like that one.
Do you prefer that one?
I do.
Okay. Visually, it's a little easier to separate them that way.
Sure is.
So do you notice anything now that you didn't see before?
There's distinctly two groups.
And by that,
28 looks like it's going to be a female.
28, you think?
Yeah, I think that 28 looks like it's going to be about a female. It looks like it's closer to the center of the dot plot.
Mm-hmm.
Whereas it doesn't look like it's in the males at all. It looks like it's below it all.
Are there any shoe print links that would make you pretty certain that the culprit was a female?
22.
Less than 26.
I heard 22. I heard less than 26. What if it were 27?
I would suspect a female.
Still female? 28?
That's pretty close to the 29, and with this being a random sample, I don't know if I would be confident.
So, depending on what the value of that shoe print length is, even though we know there are some differences by gender, we're not absolutely certain. We'd hate to make a false accusation if we could avoid it. So when we're looking at these two dot plots, we can see some clear differences. Do we see any similarities?
They both seem to have a middle and tail that's go off into the extremes.
Okay. Do we have any overlap between the two distributions?
Yes.
We do. So there are some footprint links that might not clear up the issue for us very well if we just focus on shoe print links. Any unusual values in there that you notice?
The 37.
So that one male who had a particularly long shoe print stands out. We have a couple of females who have, relative to the rest of the females, somewhat long shoe prints. Well, you're anticipating well with where we're going to head with this. I'm going to pop us back to the slideshow for a minute, and I'm going to let you keep thinking about the things that you've seen here as we look at a couple of other questions. So, in our slideshow, we were successful in comparing the shoe print links for the males and the females using Fathom, and we talked a little bit about some of the similarities and more of the differences in the shoe print length distributions that we saw. Now I wanted to ask you a couple of questions about the data production itself before we get too carried away here. In fact, one comment specifically addressed one of the things I'm going to ask about. So in this module, we're trying to help students distinguish between observational studies and sample surveys and experiments. So one of the questions that we ask is, why is this particular study classified then as an observational study and not one of the other two types?
So because we took measurements, we observed the given lengths of their shoes, their body height, and their gender rather than experimenting or asking them what their shoe length was.
And how do the rest of the folks on the call feel about that response?
I agree.
Yeah. And for me personally, I sort of like this unusual context to really distinguish between observational data and data collected through some sort of a designed experiment. So it seems like a really clean observational study.
Mm-hmm.
So why do you think the school's administrators chose to collect data on a random sample?
It'd be rather hard to get it from the entire school if it's a fairly large school.
Aha, so a census wouldn't be practical.
Nope.
Good. All right. Anybody think of another reason?
It takes care of some of the bias.
And can you elaborate a little bit on what you mean?
Well, if it's randomly done, well then each student will have a chance of being selected rather than you're looking, favoring one particular group of students.
So it's certainly more fair, would you say?
Yes.
All right. I have to stop. Yes. All right, so we've heard a couple of different ideas. Census would be not so practical. Avoiding bias is something that a random sample gives us. I'm sort of listening for a key buzzword that I often hear about why we use random samples when we do statistical design.
How about inference?
How about it?
And for input, we need representation.
Ooh, I like that word. So we're talking about you've heard the term representative sample, right?
Mm-hmm.
To hear people speaking about this sort of thing, we'd like a sample that truly represents the larger population in a school. Why do we want to why would we want a representative sample?
It would be difficult to make an inference back to the population if the sample didn't represent that population.
Well said. So random sampling is our statistical best way of trying to get representative samples.
Mm-hmm.
And hopefully in this case, the random sampling allowed us to do that. All right, let's get back to the investigation. I do like students to think about the data production, though, because there may be some limitations in the kind of conclusions they can draw, depending upon how the data are produced.
Oh, yeah.
So let's interpret some results. I'm going to ask you a couple of questions that are specific about shoe print length, and I'm going to take you back to those dot plots in just a moment, but let me show you what's coming. So the first question, question 5, is going to be about if the suspect's shoe length happened to be 32 centimeters, and the second question is going to be if the suspect's shoe print length was somewhat shorter. Okay, so keep those in mind, and we're going to take you back to the Fathom file. Here we are. So the first question was about a suspect who had a shoe print length of 32 centimeters, and I don't believe we talked about that number before. So what are your opinions about who the culprit might be?
Well, it could be a male, but I'm not totally certain.
I would say it could be a female, but probably not.
Okay.
I agree both ways.
Oh, so that's 3 people leaning toward male.
4 people leaning toward male.
Okay.
5, because 32 is higher than any of the females.
Okay.
It's like about 5.
Okay. So if you had to make a decision, would you suspect it was a male or a female?
A male.
Yeah, definitely male.
Could it be a female?
Yeah. Well, possibly. I'm looking at the dot plot.
Mm-hmm. So we want to make sure when we're asking students these questions that they continue to think about the fact that these data come from a random sample of students. And they give us some information about the larger population, that it's possible that some values are not represented here. Some of them are more likely than others, perhaps. But with 32 centimeters, it seems like we're leaning towards it being a male.
Mm-hmm.
So let me take you on to the other 2 questions that were from that slide. One was, what if the suspect's shoe print length was 27 centimeters?
Darren, I want to ask you a question.
Sure.
When you're going through it like this, do you use the word probability?
I don't. I flipped out of there. Thank you for catching it. Put it back in the box.
Okay, go ahead.
I hope you'll catch me using the word chance from now on.
All right.
So 27 centimeters, what's your opinion now?
More likely female. Agreed.
Yeah, probably female.
You all are a cautious lot. Nobody wants to find anyone guilty just yet. So you'd be excellent on a jury. You'd want to hear all the facts. What if it were 29 centimeters?
Couldn't tell.
Male or female.
So I do think it's important as students are contemplating what's going to happen with the final shoe print length, these different scenarios.
Mm-hmm.
The borderline cases, the ones that are ambiguous, and the ones that are really on the extremes.
Mm-hmm.
Obviously, we're teasing them toward the final story. But you know, there's one piece of information we really haven't used yet. You probably have been thinking about that, haven't you? If not, that height variable has just been sitting there, waiting for us to do something with it. I think now's the time. So I'm going to add another graph here in my Fathom window. And this time, what I want to look at is the relationship between shoe print length and height. So I'm going to drag shoe print length onto some axis. I had it on the x-axis or horizontal axis before. So I'm going to keep it there for now, and I'm going to drag height onto the vertical axis for now. Remember that the goal of the investigation is to try to come up with a description for the perpetrator. So might be helpful for the school administrators if we could give them something other than the perpetrator's shoe print length information, since they will already know that from the footprint that was left at the scene. So one piece of information we could give them would be gender. But if there was any other information that we could give them, it might help them narrow the search somewhat. Otherwise, they might have to call in all the females who have a shoe print length that looks like it might be near so-and-so. That might be hard to do. Do you notice anything from this new graph that we've got?
There's an increasing relationship.
Okay. So that sounds like a math teacher type comment. What might you expect students to say about the plain English version of shoe prints and height?
Bigger shoes, correlation.
Okay. I heard, did I hear positive correlation in the background?
Yeah.
Ooh. So good for your students. They have some really good vocabulary. So is it a true statement that a culprit that has a longer shoe print length, a person who has a longer shoe print length, will be taller than someone who has a shorter shoe print length?
No. In general?
Well, chances are.
Oh, there we go again. And you won't catch me with the P word this time. Because I know I'm being recorded. So you want to figure out ways to help students say what you want them to say and not say those other things. In general, as shoe print length increases, what happens to height?
Height increases.
In general. Are there any exceptions to that general pattern?
Yes.
Can you tell us about an exception that you see?
Well, we have a shoe print length of 24 centimeters and a height close to 72 there. We have a shoe print length of 30 centimeters with a height down there around 64, 65.
I clicked on the first point you mentioned. Can you see that highlighted now?
Mm-hmm.
And can you also see that person highlighted in the data table on the first row? And can you also see that person highlighted in the dot plot above? So one of the great things about Fathom is that the representations are all linked. So if you select an individual in one plot, you can look at them in all the plots in the data table. So we know who we're talking about. So what's unusual about that female?
She's really tall. Small foot.
I wonder if her name's Cinderella.
I don't know. I want to pressure you a little bit on it. So how can you tell she's really tall?
She has a longer vertical rise than some of the others.
Are there other people in the sample that are taller?
Yes.
But they're all at least 4 centimeters longer shoe print length.
So sort of around 28 or 30 centimeter shoe print length? Yeah, at least. Okay, so
she's tall for her shoe print.
Ooh, now that sounded awfully nice. She's tall for her shoe print. Does anyone see a student who is short for his or her shoe print?
Yeah, there by the 30. And then,
Yeah, that one.
This one here?
Yes.
It's a male, incidentally. Short for his shoe print. That has a nice ring to it. Tall and
unusually tall and have very large shoes.
What they look like about the proportion you would expect.
So you think they're proportional in some way? Well proportioned. So we've looked at the scatterplot a little bit, and I think it's important to have students look at individual points within the scatterplot and talk about what that individual's characteristics are. You can do it quite nicely from these connected representations. As math teacher folks and statisticians, are you thinking anything else right now?
That large shoe print's an outlier.
I was thinking outliers.
And are we speaking about this one again?
Mm-hmm.
Yep. And when you say outlier, did you mean an outlier in the x direction, the y direction? How did you mean?
I was saying both.
Or did that point sort of stand out from the whole rest of the plot?
Yeah. It looks like an inferential point.
Ooh! Wow, we got some serious statistics going on now. All right, so we have an unusual point on the scatterplot. Anybody thinking about anything else right about now?
I'm thinking I'd like to see gender on the
You want it, you got it. So Fathom allows us to do all sorts of nifty things, and one of them is grab a third variable and drop it somewhere. And look at there. I've just dropped gender into the middle of the plot. And Paul has his wish. Are you happy, Paul?
I'm loving it.
Okay. So now we can see the males and the females distinctly. I'm looking for one more statistical thought right about now that would be just dandy. I'm ready for a hint, too, if need be. What sort of general shape or pattern do you see?
Are we thinking linear regression?
Oh, bless you. That was the one I was thinking, yes. So it's actually quite easy with Fathom to add a line to a scatter plot if you think you see some sort of linear pattern. And so I'm going to right-click on my graph here and pull up a context menu. And I'm going to choose to add a movable line just for fun. The movable line will allow us to adjust the slope and the intercept of that line until we're satisfied. And then, of course, we statistics teacher types know that we could probably get the computer to fit some sort of best line to compare to. So, are you happy with my line right now?
Not really.
Not really? And what don't you like about my line other than its brown color?
It's farther away from some of the points.
Okay, so what would you like me to do to fix that?
Drag it down some so that it's closer. It has similar distances.
Okay, so I'm going to drag it down some as instructed. Down, down.
Oh, here you'll have to rotate it a bit too. Don't you want it to be the line from which the points have the least distance?
Oh! So, did you like my dragging it down okay, and now you want me to rotate it a little bit?
Yeah.
All right, so are you watching my little cursor here?
Yeah.
On the graph, so when I drag down, as you put it, you get the up and down cursor, but when you rotate, you get the roto cursor. All right, so we're going to twist it. How am I doing?
That looks good. Well, down a little bit.
Down a little bit. What do you think?
That's better.
Anybody else want me to drag it down or rotate it? A little bit? Either way?
Maybe down a little bit.
Down a little bit. Is that Rebecca?
Yep.
Those Utah people, they like it down lower. Anybody want some more rotation? So we're pretty content with that line as describing the general pattern that we see.
Mm-hmm.
And do you see down here we have an equation for our line? Height equals 34 plus 1.19 times the shoe print length. So if and when I finally give you that shoe print length, you could use this line to predict the height of the culprit.
Mm-hmm.
Does that sound reasonable?
Yep.
Okay. So I guess one of my questions is, does that particular line work well for both the males and the females? This is your impression. Does it look like it would work well for?
Seems to work better for the male.
You think better for the males, the blue points? Well,
And if you deleted the blue point, can you delete the blue point?
can I delete the blue points? Oh heavens! That's asking a lot. You've stumped the presenter.
Well, the software probably.
I think you've stumped the presenter, not the software. So let me think about that for a moment. Meanwhile, I'd like to see what the computer suggests if we tell it to hit a least squares line, a best fit line. Oh my goodness, what just happened?
Except for the males and the females, definitely.
Oh my goodness, let me undo that. What did it just do?
It says least squares line.
Oh, it pulls up two of them. Isn't that interesting? All right, so I'm gonna.
Yeah, male and female.
Mm-hmm.
I'm going to remove gender just for a second here as an attribute.
Okay.
And if you watch me doing all these things, I'm just right-clicking my mouse to get the context menu. And depending on where you click, you get the appropriate option. So I right-clicked in the middle and was able to remove that legend attribute, as it called it, that I dropped in there. And did you notice what happened now with our lines?
Yeah.
How many lines do we have now?
Well, we only have one. But
We just-
it's not counting the brown line.
Right. So it just fit a single regression line to the set of points, and I find it pretty interesting. What do you notice about our brown line versus the blue line?
Steeper.
Steeper slope, right?
Yeah.
Yeah.
Steeper slope. It seems like we were a little generous on our estimate of the slope compared to what the computer says is the best fitting line.
I think we were ignoring the outlier when we did ours.
You think?
Mm. Yeah. We're trying to get it close to, yeah.
And hadn't you pointed out to us already that that was an outlier and might be an influential point?
Mm-hmm.
And then we went ahead and ignored
Oh,
that?
blind
Well, you did the right things, and then we just ignored it. So apparently that point may have had some influence on the regression line.
Mm-hmm.
Can you take off one point?
You can.
Take off
Do that.
where the arrow is and the one that I first looked at over at 24.
Okay, so I'm going to remove this point.
Yeah.
Excuse me, I'm going to put that point back now. I'm going to just remove that point. Pardon, delete case.
Ah. That is at 24 and 71.
And to be clear, Paul, would you like me to do that with this other point removed?
Yeah, both of them are at the same time.
Okay, so you'd like the one at 24 and
Mm-hmm.
right there?
Yep.
Okay, so let's delete that case.
Uh-huh. Our eyes were, as you pointed out, our eyes were ignoring the outliers.
It certainly appears like it, doesn't it?
That's amazing.
Now, if I put that point back,
Yeah.
it's interesting to see that that point
Oh.
and there's that point back.
Yeah.
And then the line, yeah.
So it's kind of fun to be able to explore the effect of these individual points on the regression line. I think we did an okay job. We actually didn't do a very good job with that unusual point out there. Our slope was a little bit off. Well, shall we plot gender back on there?
Sure.
Because gender is an issue in the problem, and we do have information about that. So I want you to look now at the two lines that the computer has set separately for the male and the female data. What do you notice?
Oh,
Can you take off our brown one?
I can take off the brown one.
Ah, yes, yes.
Okay? So the non-rhetorical question was, what do you notice about the two different regression lines?
Well, the one for the males is a lot steeper, I think. Can't tell the difference here.
So the,
Which one is it?
yeah, the male one is the blue boxes, and it's the bottom equation.
Right. Yeah, obviously it looks like it's not nearly as strong of a line.
So the male, so I want to make sure we've all got the right one. So the male line is this one. It's got the less steep slope, 362 slope. If you focus on the blue points only and that line with less steep slope, that seems to be the best line in the sense of minimizing those prediction errors you were talking about. And then the female line seems to be quite a bit steeper, slope of almost 1, say 0.9. All right, so I have a question now that we've got the scatter plot and the two lines on here, and that is, suppose I were to tell you, hypothetically, that the suspect's shoe print length was 30 centimeters. How tall would you say the person would be?
You have the other ones coming together.
It's just
about 67 centimeters.
60,
Or
You said actually.
57, so you're going up from 30, and are you sort
between the two.
you're splitting the difference?
Mm-hmm.
Okay, all right, because we don't know for sure whether the person is male or female.
Mostly males are close to around that.
30 was in our netherworld region,
Yeah.
where we weren't quite ready to commit one way or the other. What if I told you that the suspect's shoe print length was 27 centimeters?
Then it's possibly a female.
And so in that case, would you just use the female line?
Yes.
And what if I told you that the suspect's shoe print length was something higher, like 34 centimeters?
Oh, yeah.
And you could just use the male line?
Mm-hmm.
So there's a lot of interesting information contained within the data and the scatter plot and the regression lines. But I think I've teased you long enough. I think it's time to tell you about our culprit. So when they measured the shoe print that was found outside the library, it actually had a length of 31 centimeters.
Mm.
And so the part of the investigation that we've all just done together is precisely what we wanted to have students engage and walk through and talk through and have discussion about. Now we're at the point of having them, based on the evidence, based on the value of 31 centimeters for the shoe print length, we would like them to come up with a description of the person that they believe left that shoe print for the administration. Based on everything that you've seen, what would you like to tell me about our culprit? The principal's counting on you.
Well, most likely male, but not guaranteed.
Yeah, the principal doesn't deal in gray area, so what are you telling me? Small boy did it. It was a boy.
Most likely a boy.
How tall was this boy?
Probably about 70 centimeters.
Yeah,
Okay.
69, 70.
So it looks like we're going to go searching the halls. Actually, I'm going to send my assistant principal searching the halls for a male, height of about 70 centimeters. We're going to bring them all into my office, and we're going to get them to take their shoes off.
I'm not ready to call it a male.
Uh-oh. I'm not either. Uh-oh. You're the kind of people the principal doesn't want in these meetings, right? We want to get to the answer.
Well, I'm going to say put a piece of tape 30 centimeters at the front, and anyone who walks through that door, who's right at the tape, is going to be directed to the right. Everyone else can be directed to the left.
So what you would like me to do, as in my role as principal, is to basically have the school line up outside my office and file them.
Mm-hmm. Well, in this random sample, it looks like about a fifth of the people are 70 centimeters or above, so that's not going to be too humongous.
Mm-hmm.
Well, it brings up an interesting question. If we agree, which we didn't, if we agree that it's a male that did it, probably, if we think it was a male, how far from 70 centimeters do you think that male's height is likely to be?
Give or take 2 centimeters.
Plus or minus 2, you think? So if I went looking for 68 to 72 centimeters, that would probably do it?
Sounds reasonable.
Okay. So we're raising another issue now, which is how much variability there is in the Y values of those points relative to that regression line.
Because you've got that female that has a 31 centimeter shoe print length, but she's only 65 centimeters high, 30 inches high.
Mm-hmm. Mm-hmm. We do. So what I hope that we can agree on is that students have an opportunity at this point in the investigation, as we're trying to have them draw a conclusion, to give a conclusion and support it with appropriate evidence. It is possible that that culprit is female. Is it not?
Mm-hmm.
Ladies and gentlemen of the jury, is it not possible? If you picture the defense case, my client, my male client, is innocent because it could certainly be a female. Just look. One of the females in the sample actually had a height of 31 centimeters. That's by a shoe print length of 31 centimeters.
Mm-hmm.
On the other hand, I'm the principal and I need somebody to be held accountable for this crime. And so if you tell me you think it's male, I'm going to go grab one of those boys and we're going to take care of business. So do you get a feel for how the investigation plays out?
Mm-hmm.
Yeah.
Okay, so I'm going to go back to the slideshow and show you what we accomplished. We did construct the scatter plot, and there's a little summary of the one that we produced. We took some time to interpret the scatter plot by answering some questions. Does it look like there's a linear relationship? I didn't ask that question verbatim because I didn't want to give it away. Does it look like the same straight line could be used to summarize the relationship? I didn't ask that question directly of you. And based on the scatter plot, if the student's shoe print length was 30, I did ask that question verbatim.
Mm-hmm.
I like the indirect way that you went about it, Darren. I like that a lot. I did. I mean, it wasn't, there was a method that you were going through and building up knowledge there, but it wasn't something where the answers required no thought. Well done.
Also, that wasn't a specific answer.
Mm.
And it was still open-ended at the end.
Absolutely. Well, and here is this really is the grand finality of the investigation. We want students to be able to use data to support arguments and to communicate their arguments in a way that will get their classmates and their teacher thinking and debating and discussing. That's really our ultimate aim. So,
and the key word on that page there, Dan, let me suggest is the verb write. Write it down.
yes.
Let it come out of your brain, down your arm, out your fingertips, onto the paper.
Well, and that's a difficult, as we all know from having worked with students, it's very difficult to get them to put their thoughts into clear writing.
Oh, and they don't have clear thoughts until they can.
Amen to that point.
Mm-hmm.
So let me make a couple of observations too. I'll tell you some quick background. The data were actually produced by Roxy Peck out at Cal Poly in San Luis Obispo. Students in an introductory statistics course at the college. So one of the things that we considered as an extension of the activity is you may well want to have, rather than taking students through a canned data set, it might be of interest to have students do an investigation of this sort themselves. And so we've actually done some work in our schools with having our students collect data like this from a similar scenario with a footprint that was left. And we learned that from Roxy that making the shoe prints could be quite difficult, but we found that if they stepped in water and then stepped on a piece of newspaper, that actually gave a pretty good image. We did a similar activity once with hand prints and ended up having the person making the hand prints stick their hand in Hershey's chocolate syrup. And while it was kind of funny to do that to one of my colleagues, I don't think I'd recommend that as the best way. And then the other thing that abuse, we also noticed that the issue of where you measure, the issue of measurement comes up if you have kids do the data collection themselves in terms of how they're going to measure shoe print length. We did it at the longest point of the print to try to get some kind of consistency in the measurements. But the issue of measurements certainly a very important one. So, what do you think about the investigation?
It's very thought-provoking. It makes them analyze things from various points of view.
Would you have a question that just imposed, some sort of problem that would require them making shoe prints?
Well, we actually could. The original design was to basically do what you did. Everything that you did was the full investigation, and then we started thinking afterwards of possible extensions that teachers might want to do in their own classrooms. So all you've seen is the original investigation, where we thought the data were interesting enough as they were from
measuring their shoe print
to just look at the data that Roxy collected.
Okay.
But we thought we wanted to present some options for extending it in case teachers wanted to do a little bit more. What level? I'm curious to know what level you think the investigation would work for.
Some junior high school kids, 8th graders for sure, who could do this type of interpretation.
So it wouldn't be a reach to say that it would be appropriate not only for lower high school and upper high school, but for some middle school students as well. That's a good thing. The broader, the better. So
I think the middle school fits well. I think 7th grade and up. But let me pose that question too. What's the view of everyone regarding elementary school for this analysis, just as we've done it?
I think there's elementary kids who could do this if they were being led carefully by an instructor, similar to the way we were.
I think it all depends on the wording.
Right.
I think it does too, and again, I really appreciated the skill with which you were able to do that by asking us in various ways, what do these data tell us?
some of what we're trying to capture in the teacher notes that support these investigations is those kinds of things.
Mm-hmm.
For the teacher who may not have done a lot of data investigations in class, to give them some tools and tips for eliciting the kinds of responses that you all gave so nicely, and to promote discussion rather than stifle it. I think we'd all agree that's an art as much as a science.
Yes, certainly. Yeah, and thank you so very much. This has been an excellent presentation.